This is College Algebra, Exam 3, Test 3 Review, Detailed Solution. In this exam review, we'll look at leading term, leading coefficient, and degree of a polynomial. And we'll use this information to determine the end behavior of the polynomial. And we'll use the end behavior of the polynomial to graph a polynomial function. We'll also look at the intermediate value theorem. We'll look at the long division of a polynomial. We'll look at synthetic division of a polynomial. We'll also look at Descartes' rule of sign. We'll look at number of positive real zeros, number of negative real zeros, and number of non-real zeros. We'll also graph rational function such as f of x equals x minus 1 over x plus 2. We'll look at the domain. We'll determine the vertical asymptote. We'll determine the horizontal asymptote. We'll find the x-intercept. We'll find the y-intercept. And we'll graph the rational function. We'll also look at some applications such as polynomial function application, interest compounded annually. So exam 3 test 3 review, college algebra. This is additional review to your professor instructor exam review. This is for STEM engineering college algebra students. This tutorial is a good review for college algebra, for students in college algebra, business math, development math, intermediate algebra, high school algebra 1 and 2. Note: to prepare for development math algebra support, watch my development math exam 3 test 3 review videos in addition to this. I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. Number 1 is leading term. Determine the leading term, the leading coefficient, and the degree of the polynomial. Then classify the polynomial function as constant, linear, quadratic, cubic, or quartic. A. H of x equals 2.4x cubed plus 5x squared minus x plus 7. The highest degree is 3, that means the leading term is 2.4 x to the third, the leading coefficient is 2.4, the degree is 3, then this polynomial type is cubic. B. H of x equals 8 minus 2x squared plus 3x plus 1. The highest degree is 2, that means the leading term is minus 2x squared, the leading coefficient is minus 2, the degree is 2, that means this polynomial type is quadratic. C. G of x equals 2x squared minus 9x cubed plus 15x to the 4 plus 10. The highest degree here is 4, that means the leading term is 15x to the 4, the leading coefficient is 15, the degree is 4, then the polynomial type is quartic. D. F of x equals minus 27, that's equal to minus 27x to the 0. Here the highest degree is 0. That means the leading term is minus 27, the leading coefficient is minus 27, the degree is 0. This polynomial type is then constant. h of x equals 50 plus 9x. So the highest degree is 1, that means the leading term is 9x, the leading coefficient is 9, then the degree is 1, then this polynomial type is linear. Number 2, leading term test. Select one of the following 4 sketches to describe the end behavior of the graph of the function. A, f of x equals 10x plus 4x cubed minus 7x to the 5. The highest degree is 5, that means the leading term is minus 7x to the 5. The leading coefficient is minus 7, which is negative. The degree is 5, odd. That means end behavior is decreasing from left to right, that is D. B, f of x equals 25 plus 5x to the 4 minus 12x cubed minus 14. The highest degree is 4. That means the leading term is 5x to the 4th. The leading coefficient is 5, which is positive. The degree is 4, even. That means the graph opens up, that is A. C, f of x equals minus 5x cubed plus 3x to the 5 minus 11x to the 6 plus 11. The highest degree is 6, that means the leading term is minus 11x to the 6. The leading coefficient is minus 11, which is negative. The degree is 6, which is even. That means end behavior is will open down, which is B. D, f of x equals minus 10x to the 4 plus 4x to the 6 plus 3x to the 7 plus 8. The highest degree is 7. That means the leading coefficient is 3x to the 7. The leading coefficient is, the leading term is 3x to the 7. The leading coefficient is 3, which is positive. The degree is 7, which is odd. The end behavior is increase from left to right, which is C. Number 3, zero of polynomial function. Use substitution to determine whether 4 and 5 are zeros of f of x equals x cubed minus 9x squared plus 14x plus 24. A, f of 4 equals 4 cubed minus 9 times 4 squared plus 14 times 4 plus 24. That is equal to 64 minus 144 plus 56 plus 24. And that's equal to 0. That means yes, x equals 4 is 0 of f of x. B, f of 5 equals 5 cubed minus 9 times 5 squared plus 14 times 5 plus 24 equals 125 minus 225 plus 70 plus 24. And that's equal to minus 6. That means no, x equals 5 is not 0 of f of x. Number 4 is zero of polynomial functions. Find the zeros of the polynomial functions and state the multiplicity of each. A, f of x equals x plus a to the 5 minus x minus 2 to the 3rd times x plus 5 to the 4. So set the function f of x equal to 0, that is x plus a to the 5 times x minus 2 to the 3rd times x plus 5 to the 4 equals 0. That means x plus 8 to the 5 equals 0. That means x plus 8 times x plus 8 times x plus 8 times x plus 8 times x plus 8 equals 0. That means x plus 8 equals 0. That means x equals minus 8, and the multiplicity is 5. X minus 2 to the third equals 0. That is x minus 2 times x minus 2 times x minus 2 equals 0. That means x minus 2 equals 0. That is x equals 2, and the multiplicity is 3. X plus 5 to the 4 equals x plus 5 times x plus 5 times x plus 5 times x plus 5 equals 0. That means x plus 5 equals 0. That means x equals minus 5. The multiplicity is 4. B. F of x equals x minus 1 to the 6 times x minus 9. So set f of x equal to 0. That means x minus 1 to the 6 times x minus 9 equals 0. That means x minus 1 to the 6 equals x minus 1 times 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 x minus 1 equals 0. That means x minus 1 equals 0. That is x equals 1. The multiplicity is 6. X minus 9 equals x minus 9, and that's equal to 0. That means x minus 9 equal to 0. That means x equals 9. The multiplicity is 1. Number C. F of x equals x to the 4 times x minus 7 to the third plus x plus 2 squared. Then set f of x equal to 0. That means x to the 4 times x minus 7 to the third times x plus 2 squared equals 0. That means x to the 4 equals 0. That means x times x times x times x equal to 0. That means x equals 0, and multiplicity is 4. X minus 7 to the third equals x minus 7 times x minus 7 times x minus 7 equal to 0. That means x minus 7 equals 0. That is x equals 7. Multiplicity is 3. X plus 2 squared equals x plus 2 times x plus 2 equal to 0. That means x plus 2 equals 0. That means x equals minus 2. Multiplicity is 2. Number 5 is polynomial function application. Interest compounded annually when $P is invested at interest rate I, compounded annually for T years. The investment grows to $A, where A equals P times 1 plus I to the T. Trevor parents deposited $12,000 in saving account when Trevor is 15 years old. The principal plus the interest is to be used for a truck when Trevor is 18 years old. Find the interest rate I if the $12,000 grows to $14,000 in 3 years. So manually A equals P times 1 plus I to the T. A is 14,000, it grows to 14,000 equals P is 12,000 plus 1 plus I to the third. T is 3. So divide both sides by 12,000. That is 1 plus I to the third equals 14,000 over 12,000. That means 1 plus I to the third is 7 over 6. That means 1 plus I take cubic root of both sides is equal to cubic root of 7 over 6. That means I is minus 1 plus cubic root of 7 over 6. That is I is 0.0527. That is I equals 5.27%. And here is the TVM solver, TI-84 plus TVM solver. N is 3, that is 3 years. Annual is 3 times 1, which is 3. I is leave it 0 now. PV present value is 12,000. PMT, this is for annuity, we don't care, leave it 0. FV is feature value, which is A, which is 14,000. P over C and P over Y and C over Y are 1, 1. PMT, we don't care, this is for annuity. Then just press alpha, solve, and you will get 5.272659961, which is 5.27 approximately. And here it is. So turn the calculator, then go to App, Finance, TVM Solver. N is 3 years times annually times 1, which is 3. We're going to calculate that. PV is 12,000. We put negative because this is what you are depositing. PMT is, we don't care, it is 0. It is annuity. Feature value is 14,000. That's what you will collect in 3 years. P over Y is 1, C over Y is 1. In the PMT, we don't care, this is for annuity. Then go to I and press alpha solve. And that gives you 5.272659961, which is 5.27%. Number 6 is real zero, x-intercept, turning point, given the function f of x equals x to the 9 minus 4x to the 5 plus 2x cubed minus 7. A, find the maximum number of real zeros that the function can have. Is n equals 9, the highest degree is 9. The highest degree of f of x, that means maximum real zeros are 9. B, the maximum number of x-intercepts that the graph of the function can have is, again, n equals 9, that's the highest degree of f of x, that is maximum x-intercept is going to be 9. C is the maximum number of turning points that the graph of the function can have is, it is n minus 1, which is 9 minus 1, which is equals 8. That is the highest degree of function f of x minus 1, which is maximum turning point, which are the vertexes, are the maximum is 8. Number 7 is intermediate value theorem. Given the function f of x equals x cubed plus 3x squared minus 9x minus 13, use the intermediate value theorem. Determine, if possible, whether the function has at least one zero between a and b. So a equals minus 5 and b equals minus 4. That means f of a equals f of minus 5 equals minus 5 to the third plus 3 minus 5 squared minus 9 times minus 5 minus 13, which is minus 125 plus 75 plus 45 minus 13 equals minus 18. F of b is f of minus 4, which is minus 4 cubed plus 3 times minus 4 squared minus 9 times minus 4 minus 13 equals minus 64 plus 48 plus 36 minus 13 equals 7. F of minus 5 is minus 18, which is negative. F of minus 4 is 7, which is positive. That means yes, f of x has at least one zero between a equals minus 5 and b equals minus 4. b, a is equal to 1 and b is equal to 2. Then f of a is f of 1, which is 1 cubed plus 3, 1 squared, minus 9 times 1 minus 13, which is 1 plus 3 minus 9 minus 13, which is equal to minus 18. And the f of b is f of 2, which is 2 cubed plus 3 times 2 squared minus 9 times 2 minus 13, which is 8 plus 12 minus 18 minus 13, which is equal to minus 11. F of 1 is minus 18, which is negative. F of 2 is minus 11, which is negative. That means no conclusion. Number 8 is graph polynomial function. Given the function f of x equals minus x cubed minus 2x squared. A. Use the leading term test to determine and sketch the end behavior of the graph. So the highest degree is 3, so the leading term is minus x to the third. Leading coefficient is minus 1, which is negative. Degree is 3, which is odd. That means the end behavior is decrease from left to right. B. Finds the x-intercept. The x-intercept is set f of x equal to 0, which is minus x cubed minus 2x squared equals 0. That is minus x cubed minus 2x squared equals 0. Factor out minus x squared, then that is minus x squared times x plus 2 equals 0. That means either x equals 0 or x plus 2 equals 0, that is x equals 2. So x equals 0, multiplicity is 2, that is even. That means this will not cross the x-axis, will be tangent to the x-axis. And the x equals minus 2, multiplicity is 1, which is odd, then this will cross the x-axis. Find the y-intercept. The y-intercept is f of 0, y equals f of 0, which is minus 0 cubed minus 2, 0 squared, which is equal to 0. That means y equals 0 is the y-intercept. Then graph the function. Here is the function. It decreases from left to right. Then it intercepts x at minus 2 and its tangent at x equals 0. So it decreases from left to right, it crosses the x-axis, it goes down and it comes back. This time at 0 it doesn't cross the x-axis, it bounces back, which is tangent to x-axis, and it bounces back. And the y-intercept is of course 0. Number 9 is division and factors. Given p of x equals x to the third minus 9x squared plus 15x plus 25 and d of x equals x minus 5, use long division to find the quotient, which is q of x, and the remainder, which is r of x, when p of x is divided by d of x. Expressed in the form of p of x equals dx times qx plus r of x. So d of x is x minus 5, and the polynomial p of x is x cubed minus 9x squared plus 15x plus 25. And the q of x is, we'll find this. So take x cubed and divided by x, that is x squared, then put x squared here. X squared times x is x cubed. X squared times minus 5 is minus 5x squared. X cubed minus x cubed is 0. Minus 9x squared minus 5 minus 5x squared is minus 9x squared plus 5x squared, which is minus 4x squared, and bring down the 15x. Then divide minus 4x squared by x, which gives you minus 4x, and put minus 4x here. Minus 4x times x is minus 4x squared. Minus 4x times minus 5 is plus 20x. Then minus 4x minus 4x is 0. 15x minus 20x is minus 5x. Bring down the 25. Then divide minus 5x by x, which is minus 5. Put minus 5 here. Minus 5 times x is minus 5x. Minus 5 times minus 5 is plus 25. Minus 5 plus 25. Minus 5 times minus 5 is 0. 25 minus 5 minus 25 is 0. That means r of x, there is no remainder. R of x is equal to 0. So to write this as p of x equals d of x times q of x plus r of x, that is the polynomial x cubed minus 9x squared plus 15x plus 25, can be written as d of x times q of x plus r of x. D of x is x minus 5. Q of x is x squared minus 4x minus 5. And the r of x is 0. So that's when you multiply x minus 5 times x squared minus 4x minus 5 and add 0, you will end up with x cubed minus 9x squared plus 15x plus 25. Number 10 is remainder theorem and synthetic division. Use synthetic division to find the quotient q of x and the remainder r of x of 2x to the 4 plus 7x cubed plus x minus 12 divided by x plus 3. Expressed in the form of p of x equals d of x times q of x plus r of x. So this is the same of what we did in number 9, except here we're going to use synthetic division. So the first thing is d of x, the divisor is x plus 3, and set that equal to 0. That means x equals minus 3. Then we're going to divide this synthetic divide by minus 3. And here it is. So this is 2x to the 4, 7x to the third, 0 for x squared, there is no x squared here, 1 for x, and minus 12 for the constant. Then synthetic divides by minus 3. Bring the 2 down. 2 times minus 3 is minus 6. 7 plus minus 6 is 1. Then 1 times minus 3 is minus 3. 0 minus 3 is minus 3. Then minus 3 times minus 3 is 9. 1 plus 9 is 10. 10 times minus 3 is minus 30. Minus 12 minus 30 is minus 42. That means q of x is 2x cubed plus x squared minus 3x plus 10. That is 2x cubed plus x squared minus 3x plus 10. And the remainder is r of x equals minus 42. Then to write this, p of x equals 2x to the 4th plus 7x cubed plus x minus 12 in the form of d of x times q of x plus r of x. D of x is x plus 3. Q of x is 2x cubed plus x squared minus 3x plus 10. And the remainder r of x is minus 42. That means when you multiply x plus 3 times 2x cubed plus x squared minus 3x plus 10 and you add minus 42, you will end up with 2x to the 4 plus 7x cubed plus x minus 12. Number 11 is remainder theorem and synthetic division. Given g of x equals x to the 4 minus 6x cubed plus x squared plus 24x minus 20, use synthetic division to determine whether the following numbers are zeros of the polynomial function. A, x equals 2. And the g of x is x to the 4 minus 6x cubed plus x squared plus 24x minus 20. Then we synthetic divide this by 2. So 1 for x cubed to the 4 minus 6 for x cubed, 1 for x squared, 24 for x, and minus 20 for the constant. So synthetic divide this by 2. Bring down the 1. 1 times 2 is 2. Minus 6 plus 2 is minus 4. Minus 4 times 2 is minus 8. 1 minus 8 is minus 7. Minus 7 times 2 is minus 14. 24 minus 14 is minus 10. Minus 10 times 2 is minus 20. Minus 20 minus minus 20 is 0. That is r of x is 0. That means yes, x equals 2 is 0 of g of x. B, x equals minus 1 and g of x is x to the 4 minus 6x cubed plus x squared plus 24x minus 20. Then we'll synthetic divide this by minus 1. X to the 4, 1x to the 4 minus 6x cubed plus 1x squared plus 24x minus 20 is the constant. Synthetic divide this by minus 1. Bring the 1 down. 1 times minus 1 is minus 1. Minus 6 minus 1 is minus 7. Minus 7 times minus 1 is 7. 1 plus 7 is 8. 8 times minus 1 is minus 8. 24 minus 8 is 16. 16 times minus 1 is minus 16. Minus 20 minus 16 is minus 36. That means the remainder r of x is minus 36. That means no, x equals minus 1 is not 0 of g of x. Number 12 is remainder theorem and synthetic division again. Use synthetic division to find k such that x plus 4 is a factor of x cubed plus 2kx squared minus 3x minus 6k. So d of x is an x plus 4, that is a factor. That means x equals minus 4. And we're going to synthetic divide this by minus 4. So 1x cubed plus 2kx squared minus 3x minus 6k, this is a constant. So that's 1 is for x cubed, 2k is for x squared, minus 3 is for x, minus 6k is for the constant. Synthetic divides this by minus 4. bring the 1 down. 1 times minus 4 is minus 4. 2k minus 4 is 2k minus 4. Then take 2k minus 4 times minus 4 is minus 8k plus 16. Then minus 3 plus minus 8k plus 16 is minus 8k plus 13. Then minus 8k plus 13 times minus 4 is 32k minus 52. Minus 6k plus 32k minus 52 is 26k minus 52, and this is the remainder. That means r of x equals 26k minus 52, and this is 0 because minus 4 is a 0, which is a factor. So set this equal to 0, that means 26k equals 52, divide both sides by 26k is equal to 2. Alternatively, since this x is cubed plus 2x squared minus 3x minus 6 is factorable, so you can use group to find the k. So if you group the first two and group the second two, factor out x squared from the first group, which is x squared times x plus 2k. Factor out minus 3 from the second group, which is minus 3x plus 2k. X plus 2k is common. That means if factor that x plus 2k times, then what is remain here is x squared minus 3 equals 0. Then the linear part is x plus 2k, and that's equivalent to x plus 4 to the factor. So x cancels x, that means 2k is equal to 4, that means k is equal to 2. Number 13 is polynomial with given zeros. Find a polynomial function of degree 3 with the given number of 0. A, the zeros are minus 2, 3, 5. That means x equals minus 2, x equals 3, and x equals 5. That means x plus 2 equals 0, x minus 3 equals 0, and x minus 5 equals 0. That means the polynomial is p of x is equal to x plus 2 times x minus 3 times x minus 5. And that is p of x is equal to x squared minus 3x plus 2x minus 6 times x minus 5. So p of x is then equal to x squared minus x minus 6 times x minus 5. That means p of x is equal to x cubed minus 5x squared minus x squared plus 5x minus 6x plus 30. And that is p of x is x cubed minus 6x squared minus x plus 30. B, the zeros are minus 3, 2i minus 2i. That means x equals minus 3, x equals 2i, x equals minus 2i. That means x plus 3 equal to 0, x minus 2i equals 0, x plus 2i equals 0. That means the polynomial is p of x equals x plus 3 times x minus 2i times x plus 2i. Now do first the complex conjugates. That is p of x equals x plus 3 times x squared minus plus 2ix minus 2ix minus 4i squared. The 2ix minus 2ix, they cancel each other. That means p of x is x plus 3 times x squared minus 4, I squared is minus 1 times minus 1. That is p of x is x plus 3 times x squared plus 4. That means p of x is x to the third plus 4x plus 3x squared plus 12. That is p of x is x cubed plus 3x squared plus 4x plus 12. Then c is the zeros are minus 2 as multiplicity of 2 and 1 as multiplicity of 1. That means x equals minus 2, x equals minus 2 because it's multiplicity of 2, x equals 1. That means x plus 2 equal to 0, x plus 2 equal to 0, x minus 1 equal to 0. Those are the factors. That means p of x is x plus 2 times x plus 2 times x minus 1. That is p of x is x squared plus 2x plus 2x plus 4. That is times x minus 1. That is p of x is x squared plus 4x plus 4 times x minus 1. That is p of x is x cubed minus x squared plus 4x squared minus 4x plus minus 4x plus 4x minus 4. That means p of x is x cubed minus plus 3x squared minus 4x plus 4x, they cancel each other, that is minus 4. That is p of x is equal to x cubed plus 3x squared minus 4. Number 14 is polynomial function of lowest degree. Find polynomial function of lowest degree with rational coefficient that has the given number as sum of its zeros. Minus 2 square root of 3 square root of 3i. A. Find the other zeros. That is x equals minus 2 is 0. X equals square root of 3 is 0. That means x equals minus square root of 3, which is its conjugate, is also 0. X equals minus square root of 3i is a 0. That means x equals square root of 3i, which is its conjugate, is also a 0. So find the polynomial function of the lowest degree. That means x plus 2 equals 0, x minus square root of 3 equals 0, x plus square root of 3 equals 0, x plus square root of 3i equals 0, x minus square root of 3i is equal to 0. That means p of x is equal to x plus 2 times x minus square root of 3 times x plus square root of 3 times x plus square root of 3i times x minus square root of 3i. That is p of x is equal to x plus 2. Then do the conjugates first. So do these two conjugates, that is x squared plus square root of 3x minus square root of 3x plus minus square root of 3 all squared. And the other conjugate is x squared minus square root of 3ix plus square root of 3ix minus square root of 3i all squared. And that is equal to, here the minus square plus square root of 3x and minus square root of 3x, they cancel each other, and here minus square root of 3ix plus square root of 3ix, they cancel each other. That means p of x equals x plus 2 times x squared minus 3 square root of 3 squared is minus 3 times x squared minus square root of 3i squared is 3i squared. Then this is p of x equals x plus 2 times x squared minus 3 times x squared minus 3 minus 1. I squared is minus 1. That is p of x is equal to x plus 2 times x squared minus 3 times x squared plus 3. That is p of x is equal to x plus 2 times x to the 4 minus plus 3x squared minus 3x squared minus 9. And the 3x squared minus 3x squared, they cancel each other. That means p of x is equal to x plus 2 times x to the 4 minus 9. That is p of x is x to the 5 minus 9x plus 2x to the 4 minus 18. And that means p of x is equal to x to the 5 plus 2x to the 4 minus 9x minus 18. Number 15 is 0 of polynomials. For polynomial function p of x equals x cubed plus 3x squared minus 2x minus 6. A, find the rational zeros and then the other zeros. That is, solve p of x equals 0. That is x cubed plus 2x squared minus 2x minus 6 equals 0. Then if you group the first two and the second two, then from the first group you can factor out x squared, and that will give you x squared times x plus 3. From the second group you can factor out minus 2, that will give you minus 2 times x plus 3. Then x plus 3 is common, we factor out that is x plus 3 times x squared minus 2 equals 0. That means x plus 3 equals 0, or x squared minus 2 equals 0. That is x equals minus 3, or x squared equals 2. That is x equals minus 3, or x equals plus or minus square root of 2. That means the zeros are x equals minus 2, that is a rational 0, and the other zeros are x equals square root of 2 and x equals minus square root of 2. Those are irrational zeros. And those are the other zeros. B, factor p of x into linear factors. That means x equals minus 3, x equals square root of 2, x equals minus square root of 2. That means x plus 3 equals 0, x minus square root of 2 equals 0, x plus square root of 2 equals 0. That means p of x equals, those are the factors, x plus 3 times x minus square root of 2 times x plus square root of 2. And those are all linear. This is linear, linear, linear. And those are the linear factors. Number 16 is Descartes' rule of sign. For the polynomial function p of x equals 5x to the 5 minus 4x squared plus 2x minus 3, use Descartes' rule of sign to determine A, the number of positive real zeros. P of x equals 5x to the 5 minus 4x squared plus 2x minus 3. So from here to here there is a sign change from positive to negative, from negative to positive, from positive to negative. That is, number of sign variation is 3. That is, the number of positive real zeros is 3 minus 2n, where n is equal to 0, 1, etc. That is, number of positive real zeros are equal to 3 minus 2 times 0, or 3 minus 2 times 1. That is, number of positive real zeros are 3 or 1. B, the number of negative real zeros. P of minus x is minus 5x cubed to the 5 minus 4x squared minus 2x minus 3. So there is no sign change from negative to negative, from negative to negative, from negative to negative. That means there is no sign change. That means number of sign variation is 0. Number of negative real zeros is 0 minus 2n, where n is 0, 1, etc. That means number of negative real zeros are 0 minus 2 times 0. That is, number of negative real zeros is 0. Then C is the number of non-real zeros. The degree is 5. Number of positive real zeros is 3 or 1. number of negative real zeros is 0. That means number of non-real zeros is equal to the degree minus number of positive real zeros plus number of negative real zeros. That is equal to 5 minus 3 or 1 plus 0. That is equal to 5 minus 3 or 5 minus 1, which is equal to 2 or 4. That is number of non-real zeros is 2 or 4. Then list in the table below all possible number of zeros is 5, because this is x to the 5, this is the highest degree. Number of positive real zeros, we say it is 3 or 1. Number of negative real zeros is 0 or 0. The number of non-real zeros is 2 or 4. Then add 3 plus 0 plus 2 is 5. 1 plus 0 plus 4 is 5. Number 17 is domain and vertical asymptom for the rational function f of x equals x plus 5 over x minus 4 times x plus 8. Determine A, the domain. Set the denominator equal to 0, that is x minus 4 times x plus 8 equal to 0. That is x minus 4 equal to 0 or x plus 8 equal to 0. That is x equals 4 or x equals minus 8. Then the domain is from minus infinity to minus 8. Minus 8 not included, a whole here. Union minus 8 to 4. Minus 8 not included, a whole, and 4 not included, a whole. Then union 4 to infinity, 4 not included, a whole, and to infinity. That is in the interval notation. In the set notation, it is all x where x is not equal to 4 or x is not equal to minus 8. And that is in graphic format, it is from minus infinity to minus 8. Minus 8 not included, you have a whole here. From minus 8 to 4, minus 8 not included, a whole, and 4 not included, a whole. And from 4 to infinity, 4 not included, a whole, to infinity. B, find the vertical asymptom. To find the vertical asymptom, set again the denominator equal to 0. X minus 4 times x plus 8 equal to 0. That is x minus 4 equal to 0, x plus 8 equal to 0. That is x equals 4 or x equals minus 8. That means the vertical asymptoms are at x equals minus 8 and x equals 4. Then find the x-intercept. The x-intercept this time set the numerator equal to 0. That is x plus 5 equal to 0. That is x equals minus 5. That means x-intercept is at x equals minus 5. Then find the y-intercept. The y-intercept is y equals f of 0. That is equal to 0 plus 5 over 0 minus 4 times 0 plus 8, which is 5 over minus 4 times 8, which is 5 over minus 32. That is equal to minus 5 over 32. So the y-intercept is at y equals minus 5 over 32. Number 18 is horizontal asymptom and oblique asymptom for the following rational functions. F of x equals 12x squared plus 3x plus 5 over 4x squared minus 15. Determine the horizontal asymptom. Here degree of the numerator equals degree of the denominator. That's x squared, x squared. That means y equals leading term of the numerator over leading term of the denominator. That is 12x squared over 4x squared. X squared cancels x squared, that is 12 over 4, that is equal to 3. That means the horizontal asymptote is at y equals 3. B, f of x equals x to the 4 minus x over x cubed plus 1. Determine the oblique asymptote, use long division. So here degree of the numerator is greater than the degree of the denominator by 1. That means you have oblique asymptote. We're going to use long division. So here it is. So x to the 4 minus x, write it as x to the 4 plus 0x cubed plus 0x squared minus x. These are two zeros. Then write x cubed as x cubed plus 0x squared plus 0x plus 1. Then divide x to the 4 by x cubed, that gives you x. X times x to the third is x to the 4. X times 0x squared is 0x cubed. X times 0x is 0x squared. X times 1 is x. Then x to the 4 minus x to the 4 is 0. 0x cubed plus 0x cubed minus 0x cubed is 0x cubed. Then 0x squared minus 0x squared is 0. So these are all zeros. Minus x is minus 2x. This is the remainder. That means the oblique asymptote is y equals x. Number 19 is rational function application. Medical dosage. The rational function n of t equals 0.7t plus 700 over 5t plus 6, where t is equal or greater than 10, gives the body concentration n of t in parts per million of a certain dosage of medication after time t in hours. A, finds the initial concentration, that is at t equals 10, because t is equal to 10 or greater. That is n of 10 equals 0.7 times 10 plus 700 over 5 times 10 plus 6. That is 7 plus 700 over 50 plus 6. That is 707 over 56. That is 12.625. That is n of 10 is equal to 12.625 parts per million. B, when will the concentration reach 4 million? That is n of t equals 0.7t plus 700 over 5t plus 6. That is n of t is 4 million equals 0.7t plus 700 over 5t plus 6. This 4 is 4 over 1, so do cross multiplication. That means 4 times 5t plus 6 equals 1 times 0.7t plus 700. That is 20t plus 24 equals 0.7 plus 700. That is 20t minus 0.7t equals 700 minus 24. That is 19.3t equals 676. That is t equals 676 over 19.3. That is equal to 35.026. That means the concentration reaches 4 million at t equals 35 hours. Number 20 is graph rational functions. For the rational function f of x equals x minus 1 over x plus 2. A, determine the domain. So set the denominator x plus 2 equal to 0. That is x equals minus 2. The domain is then from minus infinity to minus 2 not included, union minus 2 to infinity, minus 2 not included. This is in interval notation. In a set notation, it is all values of x except x cannot be equal to minus 2. B. Determine the vertical asymptote. Again, set the denominator x plus 2 equal to 0. That is x equals minus 2. That means the vertical asymptote is x equals minus 2. Determine the horizontal asymptote. The degree of the numerator is equal to the degree of the denominator. Both of them are 1. The degree is 1. That means y equals leading term of the numerator over leading term of the denominator, which is x over x. That is equal to 1 over 1, which is equal to 1. That means horizontal asymptote is at y equals 1. Then determine the x-intercept. This time set the numerator equal to 0, x minus 1 equal to 0, that is x equals 1, that is x-intercept is x equals 1. E. Determine the y-intercept. This is y equals f of 0, that is 0 minus 1 over 0 plus 2, which is minus 1 over 2, that is equal to minus half, that is y-intercept is y equals minus half. F, it is graph. The graph is, we know the vertical asymptote is at x equals minus 2. The horizontal asymptote is at y equals 1. We know it intercepts the x-axis at 1, and it intercepts the y-axis at minus half. And we know as x goes to infinity, y approaches 1. As x approaches minus infinity, y approaches 1, which is the horizontal asymptote. And as x approaches minus 2, y approaches infinity or minus infinity. And that is the graph. This is the graph of a rational function. And thank you. Please subscribe, share, and like. And ask your friends to subscribe, share, and like.